Well, not to mention this is a known series. You can pause the video and think about it a little bit. What kind of known series is this? Well, this is in fact a geometric series. I can rewrite that. Let me just write here. I can rewrite that as e to the minus 3 to the power of n, and that makes it a geometric series with ratio e to the minus 3. So you can use the geometric series test to conclude about the convergency, but why don't we apply the root test? All right, so an in this regard is e to the minus 3n. All I'm going to look at, let's just do everything in one shot, nth root of the absolute value an. Okay, let's do it. So nth root of the absolute value e to the minus 3n. Well, the good news is that exponential numbers, exponential functions, function just takes positive values, so we don't need to have the absolute value sign because it never becomes negative, right? So here we go. And I'm going to rewrite e to the minus 3n as the way I did here, okay? So that's e to the minus 3 to the power of n. So now I have the nth root of the nth power of an expression, and that is equal to that expression. And limit of e to the minus 3, but e to the minus 3 is a constant because e is a constant, right? So this is e to the minus 3. And what is e to the minus 3? Let's just write it as a reciprocal, 1 over e cubed. At this moment, you can use your calculator if you want to, but e is a number around like 2.71. So cubic power of that is going to be a large number, like 9, 10, something close to that, right? So 1 over that number for sure is going to be less than 1. Okay, that makes this infinite series converging absolutely. And for the same reason, since this number, e to the minus 3, is strictly less than 1, if you think this in the context of geometric series, the ratio is 1 over e cubed, which is less than 1, and geometric series converges whenever the ratio is less than 1. So you can use, again, both tests for this type of problem, geometric series test or the root test. Okay.